Language model physics is probably the most important paper that's dropped in the last few months. So break it down for us.
So, when you give let's say a language model a prompt,
Yeah.
and in this particular case, let's say it's a math problem, right? And the way math problems work is that it's a logical sequence of steps that you need to follow to get to a solution.
Yeah.
And every step typically builds on the previous one. So if you get one of the steps wrong,
Forget about it.
All of a sudden, your whole problem needs to be reworked because one of your core assumptions is wrong, and your solution doesn't make any sense at all. So what's the typical thing you would do at this point? You would go back to the model, hey, this step is wrong, correct that, and it's going to regenerate it. And if you're lucky, it gets everything right this time. But if the problem is big, convoluted, you probably got another mistake in there, and then you have to do it again. So in this process, you've burned a ton of tokens, you've lost on time, and it's not joyful anymore. So in come the paper, the physics of language models. What the team there did was, what if they asked a few questions. One of them, which I think is the most intriguing one, is what if the moment a model made a mistake, it could realize that, oh, wait, I got this wrong, right? And it could correct that. And then it talks about the reasons why models make mistakes. It's because the prompt that you put in is typically has a different distribution, quote unquote, if you will. So distribution is kind of like the world from which, you derive something. So the math problems are all from, let's say, talking about in math terms, in math text.
Yeah.
But when someone comes in English and puts in a prompt that is not as mathy, it's likely that the model would make mistakes, right? And that's typical because you can't always force everyone to have, the correct terms in making prompts. You want that to be flexible, to have a good experience, but then that introduces these uncertainties. So when you have this kind of a distribution shift, what happens is the model makes a mistake.
Mm-hmm.
And what the paper is talking about is, what if you could correct those mistakes right when they happened so that you have a better experience?
It sounds too good to be true. It's like the previous thinking is like, all right, like junk in, junk out. But the paper is talking about we as humans live in a world with physics that we understand. And the distribution inside of the model is the model's analogy of its physics, right?
Yes.
And so what are the key discoveries to actually identifying a mistake?
That's a great question. So, there are a lot of challenges, firstly, for making this happen. And that thing is, when you train a model on some data, the questions you want to ask yourself are, and this is what the paper talks about, is that, should I give it all error-free data so that it never makes a mistake? Or should I give it some data that actually has errors and corrects them, and then hope that the model gets better at not making mistakes?
Yeah.
But the trade-off is, what if the model instead learns to make mistakes? And then now you have a model that is deliberately making a mistake and giving you a correction, and that is jarring. And the problem with this part is that not a lot of people talk that way. So if you're putting out a blog that makes mistakes and talks about it, like, that's not going to happen. Like, it doesn't make sense for you to do that. It's not an engaging experience for readers. So there's a natural challenge there. So the way the paper attacks it, it's like it makes an approach where it takes a data set which is all error-free data, and it like pre-trains a model on error-free data, and then it fine-tunes it on a small set of samples where they've synthetically generated data that has mistakes.
Mm-hmm.
And even in the synthetic generation process, they consider using GPT-4, but then not do it. They take a base data set for a number of reasons that I won't go into detail of, and then they manually have some data that they generate that's high quality, just to control the fact that you don't want to get the model to make mistakes. And then when they ultimately end up testing that, the results are good, that they're promising, and now you have this model that works on grade school math problems and corrects itself whenever it detects a mistake. So the final result that you get is decent.
So you build with large language models every day. What do you believe to be true now, based on what you've discovered from implementing some of the practices in the paper that you didn't understand a year ago?
I'm very excited about this result because it's very promising for something that generalizes almost at parallel to the math space, which is coding.
Yeah, applied math, right? Like applied math.
Yeah. Computer science, again, very logical, derives on dependencies, derives on things you've done earlier, works in a stepwise process. You need to set up your dependencies, initialize your services or your variables, and that's when you can use them. So if you get your variable initialization wrong, your code isn't going to work.
Yeah.
And that's what happens in these code generations. The model makes a mistake on an earlier step.
Yeah.
And now all of the code is broken.
Mm-hmm.
Even though the latter part may be right, it needs some modifications to work. But you probably run down this work stream of agentic systems where multiple models depend on each other. And maybe your validator skipped detecting that mistake. And now you've burned a ton of tokens to generate an output that's a waste.
Yep.
But now, because you have this process where you can, fine-tune a model on detecting errors, you can have a much better experience. You can generate code that just works.
Yeah. And, code is the most complex example of if one thing is wrong, it will not work, right? It's a tree of one thing depending on another thing for something to compile to execute correctly. So we live in a world today where it's a little bit of description in, a little bit of code out, and maybe it's right, maybe it's wrong, and that makes us a little bit faster. What world, if you play this forward, does this unlock?
I think this is going to be very interesting as we go forward because firstly, we're going to have, code that is less error prone, right? There are things that have been corrected. Instead of having like a validator step to correct things, you're going to have things pre-tested and pre-corrected before the code actually comes to you, which is wonderful. But if you think about, the broader implications of this, and you can see them already. So, at the moment, there is a model, quote unquote, making waves called Reflection 70B. And it's
waves for the wrong reason. Yeah.
Probably, waves for the wrong reason. But it's building on something interesting.
Yeah.
It is definitely in the same world as this.
Yeah.
And it goes back to an idea in the space that is very popular, which is called chain of thought prompting. And what chain of thought prompting does is you give a model a prompt, you ask it to come up with a solution, all that's the same, but you now ask it to think about what it's doing and explain logically the steps that led to getting the answer. And then what happens in that process is as the model reviews its own thought process, it realizes that there's a flaw.
Yeah.
And it corrects that, and it gets you to the final answer.
Mm-hmm.
So that again is something that I believe the physics of language model paper derives from. It's going on the same idea, where you would correct things before they happen.
Mm-hmm.
And what we saw, at least in the chain of thought paper, I won't comment on the results of the Reflection 70B paper because they're debated.
Yeah.
It may have waves above like how a one-person company went against, giants, but apparently
they were just using Claude 3.5.
They were using Claude 3.5, and then when someone said you're doing that, they shifted to Claude GPT 4.0.
Yeah.
There was a ton of hype that was oversold in the space that happened, and again, it comes back to one of the earlier Blitzy bias we did on AI agents that matter.
Yeah.
Where you should not trust every single agent out there.
Yeah.
And every single benchmark. The benchmark leaderboards are broken. We live in a world where in the dark ages of Gen AI, where you don't have reliable benchmarks, where anyone can just hype everyone up and mislead them. So that was unfortunate. But chain of thought, super relevant, very powerful.
Yeah.
And that's what made the whole thing believable.
Mm-hmm.
It's been well tested by experts in the space. There are numerous papers, including physics of language models, that touch on that.
Yeah.
And it is something that will continue to drive innovation, I believe, in this space, given operating within the limitations of the models of today.
Yeah.
We do know that, OpenAI is working on Strawberry, which is supposed to be the next iteration of
Great
GPT.
name
if you will.
too, man.
Wonderful name. It's a wonderful name. And its speciality, its superpower is supposed to be reasoning.
Yeah.
And I think the name Strawberry is also pretty tricky. It probably has that for a reason. And that's because if you put Strawberry, if you ask any LLM today, one of the best ones, let's say Claude 3.5 or GPT 4.0 a while ago, if you gave it, hey, can you count the number of R's in Strawberry? It always comes up with the wrong answer. It's so good. It's consistent. It's always going to tell you there are 2 R's in Strawberry when there are actually 3. And the interesting bit is you can ask it to think through its process. And I did that. I used chain of thought prompting, and I asked Claude, why do you think there are 2 R's in Strawberry? So this is the same Claude, by the way, that is going to generate repos of code that work, right? It's going to generate like thousands of lines of code that actually work, but it gets the R's in Strawberry wrong. That's super interesting, right?
And how many are there? It's like, how many R's are in Strawberry?
Well, according to Claude, there are 2 groups of R's One that comes in the beginning where you go straw when you go straw,
Yeah.
and the other that comes in the end when you go re.
Yeah.
And it omits the R in the middle because there are two R's in re. So that's how Claude explained its reasoning of coming up with two R's. But that's exactly why, if Claude followed the way I beat that, I said, Claude, listen, whenever I give you a prompt, you're going to write code for it. And that code is going to be HTML just because Claude has artifacts and it can run HTML natively. And then you're going to give me the answer within the HTML web page using JavaScript, counting the number of letters in this character. And when it did that, it wrote the right code to do that. If only they could run code and come up with the answers themselves. Right. So that was one way to get around it. But the reason why this is a big deal is that Strawberry is going to be applying maybe chain of thought, maybe some other advanced reasoning processes, and come up with much better and more consistent answers to questions that you ask.
Yeah, I think we're excited for that to come out. I think you're in a unique spot to talk about what are the best practices today when it comes to building with multi-agent systems.
I think there are a number of things you can do. So, an agent system is which puts an LLM at the decision-making point for the next set of operations that the system will execute. And when you do that, there's a lot of challenges and constraints that you're operating under. One is that you can give this agent access to tools and then trust it with the responsibility to call the right tool at the right time in order to make a decision. But then what happens is there are a number of limitations, which is if that agent, there's a point at which the number of tools you can give an agent and expect it to use reliably, there's a threshold of I think like 20 that I've tried, after which it just starts breaking down. Yeah. It doesn't work. So you need to decide what your architecture is. You need to have multiple agents working with the same set of tools, and you need to decide what your validation strategy is. So if that agent makes a mistake and the execution flow shifts to the next one, the entire system is now operating on a mistake, right? And if you're working on a task like coding, the base model is only 65% accurate. So if you're shifting code around, you're multiplying that factor in aggregate that we talked about a few times, and you're compromising the entire system. So, and that's just scratching the surface. Now I also have to think about security, because you're probably putting valuable resources on the line, connecting them to LLMs, and you need to make sure that your integrity of the prompt that you've defined to the LLM is never compromised based on user input. So you need to have sanitization in place. You need to have all kinds of controls that make sure that the system always does what you designed it for.
Yeah, and why should anyone even listen to you? Tell me, what's the max number of agents that you've had work cooperatively in a system successfully?
We've spun up agents dynamically using the frameworks and tools out there. And at one point, one of the recent solutions we built, it had 40 agents, roughly 36 if you want to be precise, that were coordinating and getting a step done. And I think that was, in terms of the depth of the graph, this in LangGraph you have a depth. I think we were at a depth of like 500, getting things done, getting outputs validated and spun out. And we had humans in the loop, of course, validating this process. So we've built these complicated systems. We've been toying with the tools and implementing them in production, going beyond that right since the day they've come out. So we're speaking from a lot of experience of having done things wrong in order to figure out how to do them right.
Yeah, and talk about the role of Langsmith, which we found to be incredibly useful in going from really wrong to really right.
Yes. So, when you're putting systems out there in production before users, these could be internal or external, everyone is bombarding them with all kinds of prompts. Your agents are talking to each other with prompts. You need a way to be able to track them, trace them, and figure out, what's going on. Like, what are the places where my system can break? What are the improvements I can do today to change things? Which prompts need to be updated, if you will? And then you could use some other tools to do that, but Langsmith is just so deeply integrated into the LangChain and the LangGraph ecosystem that it's just easier to work with them. You can just have you can just define the environment variables for them, and that's pretty much all you need to do. It keeps traces of every single run,
Yeah.
and you can track them and debug them.
Yeah, it's like the Google Tag Manager of
Yes.
AI programming.
Yes,
is the way I think
absolutely.
about
That's
it,
accurate.
for all the marketers out there.
Yep.
Yeah, it gives you like a level of visibility into what's actually going on, and what we initially were building, which was a black box system, has become totally transparent on what's
Yes.
going on in a way that just rapidly accelerates the pace of development. So,
Yes.
what else is top of mind in AI for you right now?
I think I'm excited to see the next generation of updates in the models. The thing that's been happening lately that's been particularly intriguing me is how easy it is, to just fine-tune models.
Yeah.
That's one thing. The people putting out versions of models every day, and how easy it is to generate hype. But another major concern has been that you would expect Claude 3.5, which is a model version, to be consistent all the time, right? Like if you gave Claude a prompt, it generated, let's say, code for you or some text for you, you would naturally expect it to have the same level of quality when you come back and you put that system maybe in production, right, with the same model.
Yeah.
But apparently that's not the case.
Yeah.
So what the industry has been observing of late is that the models are degrading and upgrading in quality unpredictably. So, ChatGPT 4.0 latest, for example, right, which is OpenAI's supposedly flagship model that's inside ChatGPT, at times it tends to beat Claude 4.0 in coding tasks. So there was a time when that was happening, and that was because Claude 3.5 Sonnet had actually downgraded in quality for whatever reason. Like people who were playing with it day and night were noticing that Claude wasn't completing the answers. Claude was being lazy at times.
Yeah.
It was hallucinating more than usual. And then in that moment, GPT-4o shot up. And then more recently, Claude 3.5 is back. So that kind of uncertainty in the space leads you to believe that there's still a lot of progress that we need to see in the models and the APIs, and then the model providers need to do a little bit better on versioning.
Yeah.
I saw how ChatGPT, OpenAI sort of kind of addressed this, but not really with ChatGPT. So what they said is like, hey, this ChatGPT latest will always have an experimental model tied to it. So things will change, things will break, expect that. But if you want something more stable, here's a version identifier that you can use.
Right.
And Claude 3.5 Sonnet has that. So these companies, they do need to iterate and experiment, right? They're working against the laws of efficiency internally.
Yeah.
So they want to make sure that you get the best quality at the right trade-off cost for them, and you get it as fast as possible.
Yeah.
So that's another line of trade-off, right? So they have to experiment, but I think they need, as the space evolves, we'll probably see more consistent version identifiers, and hopefully we can expect those version identifiers to be constant and have the same quality every time you put in that same
It's hard because you want to be using the latest frontier edge of the model and everything that you're doing, because it's substantially different than the last version. And so it's hard to be able to hang on, we're going to go like the version before this to be consistent versus let's just see how this one does. It sort of feels like the only source of truth on how the latest versions of the models are operating on a hour by hour, day by day basis is Reddit. Like Reddit's where all the real builders are at and commenting. So thanks, Alexis Ohanian, for starting that a couple of decades ago. At this point, where else are you able to actually get real signal on what is going on at the frontier edge of these models as they're continually experimenting?
I think Reddit is definitely my primary.
Yeah.
There are some spaces on Discord as well that are quite active and talk about it. But I think in terms of like tinkering with the models, in terms of being up to date on what's happening and how fast the space is evolving, LangGraph and LangChain is something that changes their APIs every now and then.
Every now and then.
And then if you go to Claude today, like right now as you're watching this video, which is going to be sometime after we recorded it, and you ask Claude to give you something that works with LangGraph, it's not going to be able to do it. Just because its training cutoff exceeds all of the changes that are happening in LangGraph. But let's say you get lucky and you do get a prompt, you get a response that has something, go ahead and put that in your IDE. You'll get a complaint that it's already deprecated. So the API that you're using, and that's from like 6 months ago, has been already deprecated and changed.
Yeah.
So that's a challenge that we're solving with our platform, because we're always up to date on the latest APIs and the latest guides surrounding those APIs.
Yeah.
So when you build a solution using, let's say, even Claude on our platform, it does better because Claude has all the latest up-to-date context, and it generates exactly what you want. And that, I think, personally is a boon to me to using the space. Like, I'm the biggest super user of our product, just because I'm using the product to build the platform. And that is insane. I don't think you could do that even a year ago or 6 months ago, right? So just because I now have access to all of the latest APIs, I have access to all of the knowledge from Reddit that I can crawl and ingest. I have access to all the guides that people put out, and that could be on the official documentation, it could be on Stack Overflow, it could be on Reddit, it could be on Discord. I can ingest all of that and now generate code that just works and learn from the community. I think that is something that you could not do a while ago.
It's funny, when we were initially going and raising capital, some of the VCs that were skeptical would be like, well, if what you're saying is true, you could use your product to build your product. And we were like, and they were like, I'm out. Like, it's too meta. It's not going to happen. And now we're literally doing it every single day in a way that we're able to move exponentially faster. Than with a very small team. So.
And it's crazy. It's like, I think it's hard to see how fast the space is evolving. And to predict, what's going to happen next. But the fact that, we've been on the ground playing with these things, building systems with them, finding out where the flaws are, finding out where the frontier is of knowledge, of efficiency, of quality, we're able to, predict a little more accurately what the next step and what the next meaningful improvement is. And we're able to address some of those shortcomings and build products that, our users will love.
So should we wrap on the biggest takeaway from the paper and how that is updating your thinking on what the next future step is going to look like?
Yes, I think the biggest takeaway from that paper and from all of the recent happenings in the space are that chain of thought is super promising. Reasoning, anything you can do to help the model reason through what it's giving you and correct its mistake early is super helpful. So you don't have to deal with wasted prompts, you don't have to deal with longer inference times.
It's exponentially helpful. That's what's so interesting about it. It's not like, oh, this is a 30% improvement. Like, if you can do this well, you can then build agentic systems that were previously dependent on the other thing being right and get it right and really build complex systems where I think 6 months from now, while we're proud that we built a system that has 36 cooperating AI agents today, I think we'll be increasing by orders of magnitude if we're able to apply this really thoughtfully and correctly.
Yes, and given how easy it is to fine-tune models today, I think if you're an advanced developer in the space, you should totally give it a shot to maybe even generate synthetic data using one of the top models, like let's say Claude, for chain of thought, and then fine-tune a model on that, maybe fix the model to correct the mistakes before they happen, as the paper predicts. And then maybe you could put out your own model. Just don't put Claude 3.5 behind it as the open source.
Just cite it correctly. Cool. Well, good one, man.